Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are studying topic number 9.9, diffraction of light. Okay, we are studying diffraction of light. So, first, let's have a look to the definition. The definition is the spreading of light. The spreading of light waves around the edges of a narrow opening or we can say the bending or the spreading of light waves into a region behind an obstacle is called diffraction of light. Okay, the spreading of light around the edges, we called it the bending of light or the spreading of light. So remember, diffraction of light is the wave property, so it supported the wave nature of light and it follows inverse square law. What does it mean? It means as the distance traveled of the light is increasing, the intensity will decrease by square times. So decrease in intensity will be by square times. Okay, so remember, for the diffraction you should remember these 2 points. Look at point number A. The diffraction effects are produced when a beam of monochromatic light passes through a narrow slit. Okay, look at point number 2. These are actually the condition of diffraction. The diffraction effects are produced when a knife edge is placed or is held against a monochromatic light. Mono mean one, chromatic mean color, single frequency light source. Okay, the diffraction of light waves around the knife edge produces the pattern. So one is the interference pattern, the other is diffraction pattern. The difference between them is the diffraction pattern is unequally spaced. The interference pattern is equally spaced while the diffraction pattern is unequally spaced. Okay, so look at, we have a source that is called the primary source and this is the opening. Okay, so remember, this opening is called D. This small opening is called D. From here to here, this small opening is called small d. So D is called the slit width. So remember, the condition for diffraction is the wavelength of incident light should be greater or equal to the slit width. The wavelength of incident light should be equal to or greater than slit width. If this condition is satisfied, then diffraction may occur. Okay, so this width is very important for the diffraction. If it is smaller than the wavelength, then diffraction may occur. Okay, so when the light comes and the light will be diffracted. So when the light will be diffracted, so on the screen we will observe a brighter spots and a dark spot. This is a dark spot. A brighter spot and a dark spot. A brighter spot and a dark spot. A brighter spot and a dark spot. Look at here. A bright spot and a dark spot. A brighter spot and a dark spot, and so on. So look at here. At the middle of the screen, the brighter spot is very large, means it has very high intensity. So if I draw the waveform, so its amplitude is very high, its amplitude is small, and its amplitude is further small, and it is further small. So it means that, so look at the amplitude of dark is 0 because it has no intensity. So its amplitude is get smaller and smaller. So at the middle the amplitude is very high. It means that whenever the path difference is 0, the dark spot will be appear. So its amplitude is very high, and here it is lambda, it is 2 lambda, it's 3 lambda, and so on. Okay, these are the path difference of the bright, and the path difference for the dark is lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, and so on. So the width of the dark is gradually increasing as we increase the distance, because it is following inverse square law. Whenever the distance is increased, the intensity of the light will be decreased. So at the middle, the bright high intensity of light will produce. But if we move through a larger distance, then the dark spot will increase. It means that the intensity of light will be decreases. So this is all about 9.9. Topic number 9.9, diffraction of light. If you have any query, then you can ask in comment section. Okay, take care. Allah Hafiz.